So if you like watching movies, you might have often noticed that the smart guy writes thousands of equations on a board, and some of those equations look somewhat like this. Now let's see what these equations are. Now, these fancy looking equations that you see, they have a special name and they're known as polynomial equations. Now, the general form of any polynomial equation is a1 x powered n plus a2 x powered n minus 1 plus a3 x powered n minus 2, and you keep going till you get an x powered 0, okay? This equals an f of x, and f of x is basically a function of the variable x. Now, when n equals 2, you get a1 x powered 2 plus a2 x powered 2 minus 1, which is 1, and a3 x powered 2 minus 2, which is 0. As you get a 0 over here, you stop. You don't need to include any of this. And the RHS, the right-hand side, is the f of x, which is 0. So this equation becomes a1 x squared plus a2x powered 1, or just x, and a3x powered 0, or just a3, as any number powered 0 is 1. Now these equations are what you call quadratic equation. So how do you know it's a quadratic equation? The highest power of x is going to be 2. So that's how you know it's a quadratic equation. So now let's consider an example of a quadratic equation. So this is the general form of a quadratic equation as you saw in the previous slide. And this is a simple example. So when we compare this equation to this one, you can observe that a1 is 1, a2 is minus 3, and a3 is plus 2, and the RHS is 0. So the first and the most basic method of solving an equation like this would be to keep putting in values for x so that you make this equal to 0. Okay, so that because it's an equal sign, so the left hand side, the LHS, needs to be 0. Okay, so let's consider when x is 0. So when x is 0, you put 0 in the value of x. So you have 0 squared minus 3 into 0 plus 2. Okay, so this is 0. Anything into 0 is 0. So you're left with a plus 2. Now 2 is never equal to 0. So you can conclude that x equals 0 is not a factor of this equation. Okay, not a factor. That's a very bad cross, but I hope you understand. Now, moving on to when x equals 1. Now, when x equals 1, you get 1 squared minus 3 into 1 plus 2, which is 1 minus 3 plus 2, which is minus 2 plus 2, which is a 0. Now, this left-hand side equals the right-hand side. So you can say that 1 is a factor of this equation. 1 is a factor. When x equals 2, you get 2 squared minus 3 into 2 plus 2, which is 4 minus 6 plus 2, which is a minus 2 plus 2. This also is true as 0 equals 0. So x equals 2, 2 is a factor of this equation. Now, since you've received two numbers which make this equation a 0, you can stop looking for more numbers, as it's known that if the highest power of x is a 2, you can only get two values as solutions. Okay, so one value is 1 and the other value is 2. So 1 and 2 are the roots of the equation. Now, for some equations, if you keep plugging in values to find out if it equals 0, it might take forever. So there is an easier method. In this method, you find that two numbers whose product equals the first and the third. So here it's 1 and a3 is plus 2, product is plus 2. So the product of the two numbers should be plus 2. And then you denote either by addition or by subtraction how are these two terms forming the middle term. So how do two terms whose product is plus 2 form a minus 3? So let's consider 1 and 2. The product is 2. And if you realize minus 1 and minus 2 equals a minus 3, which is the middle term. So remember minus 1 minus 2 and you split this equation to this. So you get x squared minus 1x minus 1x minus 2x plus 2 equals 0. So here the common term is x, so x into x minus 1. Here it's minus 2, so minus 2 into x minus 1 equals 0. Now x minus 1 is common in both of these terms, so you put x minus 1 in a separate set of brackets, and the remaining terms are x and minus 2, so that goes in a separate bracket. So this equals 0. Now when can the product of two terms be 0? When either of them is 0, right? So when x minus 1 is 0, you put the minus 1 in the right hand side, so x equals 1. When x minus 2 is 0, you put the minus 2 in the right hand side, so x equals 2. So the roots of this equation over here are x equals 1 and x equals 2. Now, there is a formula by which you can directly find out the roots of any quadratic equation. The formula is x equals minus b plus minus square root of b squared minus 4ac divided by 2a. So, for this formula to work, you assume a1 as a, a2 as b, and a3 as c. Okay, so using the previous equation, you get b as minus 3, the a becomes 1, and the c becomes 2. So if you just put in the values for this formula, you get minus of minus 3 plus minus square root of minus 3 squared minus 4 into 1 into 2 divided by 2a, which is 2 into 1. This results in 3 plus minus square root of 1 entirely divided by 2. Square root of 1 equals 1. So you consider two cases, one for plus, the other for minus. So 3 plus 1 by 2, 3 minus 1 by 2, which equals 4 by 2 and 2 by 2. 4 divided by 2 is 2, and 2 divided by 2 is 1. Now, there is a concept in quadratic equations known as a discriminant, denoted by the capital D, which is the middle term squared minus 4 times the first and the third terms. Now, if discriminant is positive, the roots are real numbers and they're not equal. If D is negative, the roots are imaginary numbers and they're not equal again. Although, if D is 0, both the roots are real and equal. Now let's try solving a question. So if the total resistance of this picture over here is 2 ohms, what is the value of each resistor? So in physics, you might have learned that for a parallel system of arrangement of resistors, the total resistance R total is 1 by R total, which equals 1 by R1 plus 1 by R2. So R total is 2 ohms, R1 is X ohms, and R2 is X plus 3. So this is what you get by cross multiplication and simplification. You get this quadratic equation, and the factors of this equation are minus 2 ohms and plus 3 ohms. Now, if you'd like to see how this works out, you could always pause the video. Now, as you know that we cannot actually have minus 2 ohms as resistance cannot be negative, so the answer is plus 3 ohms over here. So R1 is X, which is plus 3 ohms. R2 is X plus 3, which is 3 plus 3, which is 6 ohms. Now let's try finding out the discriminant of this equation. So the discriminant is b squared minus 4ac. So a is 1, b is minus 1, c is minus 6. So plugging in the values, you get a 25, which is a positive value. This denotes that both the roots are real numbers and they're not equal. So this has been confirmed when we solved the question. We got minus 2 and 3, which are roots and are real numbers which are not equal.